You are listening to the Break Time Tech Talks podcast, a bite-sized tech podcast for busy developers, where we'll briefly cover technical topics, news snippets, and more in short time blocks. I'm your host, Jennifer Reif, an avid developer and problem solver with special interest in data, learning, and all things technology. Every time I come across a situation where I have to map relationships from database entities into an application, I feel like I have to refresh my memory on how to do that. So I want to talk a little bit through that, and maybe talking through it will help it stick for me. Then I'll cover what is probably one of the banes of developer existence, software project estimates, and one author's take on doing it better. So to start off, I wanted to look at how to map relationship entities in applications, specifically looking at graph database entities. If you're dealing with a graph database and the entities that are there, you have nodes and relationships, so your objects or your entities in the database, and then the connections, relationships between those entities. And mapping this in an application isn't really all that complex, but it is a little bit of a different mindset. And if you don't do it often, as I don't, then it can be a little bit of a hassle to refresh your memory. Specifically, I'm talking about working with Neo4j graph database and Spring Data Neo4j relationship mapping in a Java application. But let's talk a little bit about the graph end of things first. Graph treats entities and relationships as equally important. The relationships are as valuable as the entities themselves. But there is a little bit of a rule with this. You can't have relationships without the entities to connect. After all, what good is a connection without an endpoint? Think about a flight. You have to have a starting point, a takeoff point, and a landing point, right? You can't just have the flight. It has to have a direction. It has to have an ending somewhere. Relationships then are still somewhat dependent on the entities they're connected to. In an application mapping, this proposition still holds true when you map them with a mapping library. For instance, if you're dealing with a relational database, you've got an ORM or object relational mapper. In a graph database, you have something similar, but it's called object graph mapper or OGM. I found a couple of things when doing this that I have to remind myself of. First, you can't load relationship entities directly without a relationship node. This makes sense, as we just talked about. Graphs, while they elevate the relationship as equally important, you can't have a relationship without connected endpoints, a start and an end node. Same thing here with an application entity. You can't just retrieve a relationship. You have to have a connected endpoint to that in some way. That's the first thing. Then you only need to define a separate entity for that relationship in the application when you want to map properties from that relationship from the database. This is similar to when you have a relational database, for instance, and you have a one-to-many relationship, you just map straight table to table from one entity to the other in your application, and it's a relationship property there. But when you have a many-to-many relationship, you have this associative entity table or join table that you can include additional properties for that relationship, and you map that in-between entity. In the graph space, that relationship just becomes an associative entity. But again, if you don't really care about the additional properties on that relationship, you don't have to map it. So that's the second thing. Third thing is the relationship properties class that you define for that relationship entity has to have an ID field, which is not just a unique property value, but the internal ID of the database entity. Now, if you're familiar with the way Neo4j or maybe MongoDB creates database entities, they create this internal ID for every node relationship in the Neo4j case and every document in the Mongo case. And it's this internal ID that isn't best practice to utilize on the front end for users. You want a technical key or a business key to uniquely identify that entity, but it's an internal ID that you can use to always reference a unique entity in the database. You need to map that in your application class. Again, you don't have to display that to user, but it must be mapped internally in that application class. Neo4j used to use a long data type for internal IDs. They've now migrated that, changed their internal ID structure, and they now recommend mapping a string with the annotation at relationship ID. So that includes the at ID and at generated value annotations together for Spring Data people. So those are the four things. So you can't load a relationship without a connected node. You need a separate relationship entity only when you want to map the properties on that relationship. You have to map that internal ID in the application class for that relationship. And then it's now migrated from a long ID type to now a string ID type. So those are the 4 things I have to keep in mind. Hopefully I'll remember that next time I work with this. The article I wanted to look at was a fun one to read, honestly. It's called Software Estimates Have Never Worked and Never Will. This one was a little bit entertaining, I'll say, and a little bit too close to home. My previous job, I did a lot of software estimates for every project we worked on. The most frustrating thing being that no matter how hard I tried, I could never improve my project estimation skill. I would always be wrong or unforeseen circumstances or not realize what we didn't know and things like that. I always like to approach any new task as I can learn this, I can improve at this, I can get good at this, right? Humans want to tackle things that they can achieve or that they can be successful at or get better at. Software estimates, I never felt like that was the case. You were just taking a shot in the dark and playing your chances every time. It was really frustrating to me. I never felt like I could succeed there. It's really demotivating. So the author talks a little bit about this. People have tried and failed to estimate even medium-sized projects. And then you look at larger projects, and that's even more difficult. We keep trying to tell ourselves it gets better, but it doesn't get better. It's not any easier the next time around. The fundamental problem that the author says is that as soon as a type of software development becomes so routine that it would be possible to estimate, it turns into a product or a service you can just buy rather than build. Very few customers need to custom build off-the-shelf solutions today. So therefore, the bulk of software development is focused on novel work. This was the component that just blew me away. The problem that we have is when software becomes so routine and so consistent that we can estimate it, somebody turns it into an off-the-shelf product. And most people don't need customized solutions. They can use an off-the-shelf product, at least for the most part, maybe a couple little customized tweaks here and there. But okay, so you've got this off-the-shelf solution. You don't need to custom build it. Then anything that you do need to custom build, it's all new work. It hasn't been done before. Nobody knows exactly what it should look like until you start building it. Then you can only articulate what you've done or how long it's taken after building half of the wrong solution, changing the direction, and then coming up with something better. Well, you take it down one path. Oh, nope, this didn't work. Back it up. Let's try a different path. The author says it's time to accept this process. Now, before you get completely demotivated and feel like this is depressing, why are we even doing this? We shouldn't be doing this. I can't ever get it right. It's not entirely hopeless. We can actually change tactics a little bit. An alternative method for producing software is to constrain projects to budgets, or the author terms as appetites in the shape-up methodology. The author says that programmers are surprisingly good at delivering great software on time if you leave some scope open to negotiation during development. The author does give it the caveat, you're not going to get exactly what you asked for, but I really love this line. You wouldn't want that because what you asked for before you began building was based on the absolute worst understanding of the problem. You don't know what you don't know until you start building something and go, oh, that's not right. That's not what we wanted. Let's backtrack that and fix and try again. To me, as an outsider looking in on this article, it sounds like a very iterative, incremental development approach, which is what a lot of software methodologies are based upon. You can't build software by sitting down and going, I need these 16 different features all to do this overall big high-level thing. It's much more efficient and much better to approach, okay, I'm going to build this one feature in. Okay, that's working. Now let's add this other feature. Now let's do this other thing. So why can't we adapt software estimates to take that same approach? Do this iterative, maybe a little bit more agile approach to software estimates instead of that traditional waterfall where we take this big project or this big application we break it down into pieces, we estimate all those pieces and roll it up and say, okay, we can release this in 6 months or a year or whatever. We don't do software releases like that anymore. So why are we doing estimates like that? I really liked this article, thought it was a little bit fun and entertaining to read, as well as just thought-provoking and produce some new ideas that I hadn't thought of before. In closing, I documented how to map relationship entities from a graph database to an application, and then we delved into one author's viewpoint on software project estimates and some ideas to adapt this inaccurate process for better results. As always, thanks for listening and happy coding.